Good morning, all of you. So, today's class we are going to study about the bioacoustic signals. So, the bioacoustic signals are the sound signals which is produced by our human body. So, we call it as bioacoustic signal. So, in the bioacoustic signals, we are going to study about some of the signals like auscultation, then breath sounds, speed signals. So these signals we are going to study as under bioacoustic signals. So sound signal which is produced by the human body, we call it as bioacoustic signals. In short form, we call it as BAS. So these signals are audible and it is emitted by the human body based upon the function of each organs. So if you see the bioacoustic signals, the that is the sound which is produced by the heart, that is heart sounds, so which can be heard by the stethoscope, so that is also considered as a bioacoustic signals. So here when you see the microphone is used to pick up the sound, and this microphone it converts the mechanical energy into an electrical energy. Then later on the signal is digitized and analyzed using some computer based algorithms. So we have to properly extract those bioacoustic signals and process it and convert into a readable form to analyze the signal. So apart from the heart sounds, we have some of the bioacoustic signals are lung sounds, bowel sounds, joint sounds. So these are some of the bioacoustic signals. The first one, let us focus on auscultation. So monitoring the heart sound over the chest wall, we call it as auscultation. So why do we go for monitoring the heart sounds over the chest wall? So if the people having any pulmonary dysfunction, so definitely during the respiration process, the gas flows through various pathways, um, airways. We call it as airways. Inside that, starting from the mouth to this windpipe, we call as a trachea. The air is flowing. So these, when the air flows to the different organs, it emits the acoustic energy, or we call it as a sound energy. So this energy, this acoustic energy, it is transmitted through the air walls, that is starting from the lung tissue and the chest walls. So these walls, it generates the sounds which is called as the breath sounds. It is generated by the air which is entering into the alveoli through the inspiration process, and while it the air passing through the larynx. So through this the breath sounds are used produced. So if you see there are four types of breath sounds: normal breath sounds and abnormal breath sounds also there. In the case of normal breath sounds, we have vesicular breath sounds, bronchial breath sounds, bronchovesicular breath sounds, we call it as BVBS, tracheal breath sounds. Then some of the abnormal breath sounds are cogwheel, asthmatic, amorphic, and cavernous. And adventitious sounds, which is due to the when the people have wheezing problem, so they have that produce some different kind of sounds which called as adventitious sounds, which is very loud in intensity. And usually this auscultation is performed with the stethoscope and a microphone, and the frequency range of the sound varies between 20 hertz to 2 kilohertz. And here the signal processing method used to process to analyze this signal breath sounds are parametric description method and automatic classification method. So these are the methods used to analyze this breath sounds. So if you see the lung sounds, it is divided into normal lung sounds and abnormal lung sounds. Normal lung sounds we call it as NLS, abnormal lung sound we call it as ALS. So the normal lung sounds are the sounds it is heard over the specific location of the chest during the breathing in healthy subjects. So there are different types, as already I have told you: tracheal lung sounds, which is called as TLS; vesicular lung sounds, which is called as VLS; bronchial lung sounds, which is called as BLS; bronchovesicular lung sounds, which is called as BVLS. So this tracheal lung sounds, it is heard over the trachea having a very high loudness. And this vesicular lung sounds, it is heard over the dependent portion of the chest, but not to the immediate proximity to the central airways. Bronchial lung sounds, it is heard in the immediate vicinity of the central airways, and bronchovesicular lung sounds, it is heard at intermediate location between the lung and the airways. So these are the normal lung sounds. The normal crackles are there, which is denoted as NC, inspirately lung sound, which is heard over the anterior or posterior lung bases. And some of the abnormal lung sounds are wheezes, musical CAs, and rhonchi, stridors, stridors. So these are the lungs abnormal lung sounds, which is caused during the expiration process, particularly by any obstruction in the central airway, usually near the larynx. It creates the crackles or discrete explosion or non-musical kind of abnormal lung sounds. Then the next, after this breath sounds and auscultation, the third signal we have acoustic signal, we have voice. So voice is nothing but the speech. So how the speech is produced? The speech is produced by the air which is expelled from the lungs through the trachea to the vocal cords. So when the vocal cord utters the sounds, what happens? The voice or vocal cords forced to open the way the means of air pressure. The opening slit we call it as glottis, and this pulse of air, it propagates through the vocal tract, and it produce through this way we can able to produce the speech. So this air, it travels through various tubes and cavities of the vocal system, and due to that we can able to produce the speech. And the frequency of oscillation of vocal cords during the voiced speech, we call it as fundamental frequency or pitch. So when we utter the voiced unvoiced sounds, the vocal cords are kept open, and these do not take part in the sound generation. So the speech signals mainly used for diagnostic aid for laryngeal pathology or some disorders like laryngitis, cancer, paralysis, and hyperplasia. And it is mainly used to diagnostic aid for some neurological diseases, and it is indicator of an emotional states. Then the fourth sound, we call it as Korotkov sound. So it is mostly measured by using indirect blood pressure measurement called sphygmomanometer. So you know the procedure, the sphygmomanometer device. So in which there will be a mercury manometer, a cuff it is attached to it, a rubber bulb will be there, and this cuff will be placed over the upper arm, and then you will be having a rubber bulb. So the rubber bulb will be pressed, and with the rubber bulb is pressed, it is connected to the cuff. So we are increasing the pressure above the atmospheric pressure. So that time the blood flow will be restricted in the blood vessels. So we are increasing the gradually increasing the pressure above the atmospheric pressure. So that time the blood flow will be restricted. Then after sometimes what will happen in that mercury manometer, the pressure level rises. It will rises till above 120, above 120, like 140. After that they'll be slowly releasing that pressure. So that time what will happen, here the blood flow will be there, that is be a turbulent flow. So the turbulent blood flow, it generates the sound, so that can be heard using the stethoscope. So the sound which is produced, we call it as a Korotkov sound. So that time when the pressure decreases and then it reaches at 120, we can able to hear the Korotkov sound. First sound we call it as Korotkov sound. Then after again the pressure is slowly released. At the second point we are hearing the next sound, we call it as diastolic sound. So that time we are generating the blood pressure. The blood pressure is being generated as 120 per 80. 120 for systolic pressure, 80 for diastolic pressure. So the frequency range of the sound, it varies between 150 to 500 hertz, and the amplitude is 100 millivolts peak to peak. So thank you.